Hey everyone, it's Justin again. In this lesson, you'll learn how to perform translations. Translations are another type of transformation that we get to explore in this unit. By the end of this lesson, you should be able to perform translations of figures. First, we'll explore what a translation is, and then we'll complete two examples. Translations are everywhere around us. Take these stairs, for example. They show us a horizontal translation to the right and a vertical translation down. A translation is simply a transformation that moves a figure to a new location by sliding it horizontally, vertically, or both. These windows are set up in a horizontal translation to the right. Even these chairs are arranged in such a way that they shift to the right. And the reason this rug is so appealing is because it has the simplicity created by shifting triangles to make a pattern. Take a moment now by pausing the video to look around the room you're sitting in. Be creative and try to count how many translations you can find. There are even more translations everywhere you go, so keep this idea in mind as you go to different places. I'm also wondering if you noticed me use the word shift or shifting when I was talking about some of the translations. Shift is just another word for translate, so you can think of them as the same thing as we go through the lesson. Let's try our first two examples for this lesson. The first example says to translate the object 2 units left and 4 units down to find the following information. We could start by filling in the points on the pre-image by looking at the given graph. Pause the video now and find points A, B, C, and D. Take a second to double check your work with mine. We were only asked to find the vertices of the rectangle, but remember, there are many more points, actually infinitely many points, on the sides of this rectangle. So, we were asked to shift the rectangle 2 units to the left and 4 units down. You can use addition and subtraction to calculate the location of your new points, but the easiest way to find them is just by counting units on the coordinate plane. Try sketching the new rectangle on your own. Here it is. When making your sketch, did you label the vertices on the image? If not, do that now. When labeling our new vertices, it can be helpful to lightly sketch in the arrows that will help us visualize the changes. For example, when we're finding a prime, we can use arrows to show that we're moving left 2 spaces and down 4 spaces. We could do the same for the other vertices, just to make sure that they're in the right place too. Then, we write the coordinates for A prime, B prime, C prime, and D prime. Before we finish answering all the parts of this question, I want to ask you one more thing. What do you think would happen if we moved down 4 units first and then 2 units to the left? That's right. We still would have gotten the same image. That's not super crucial to our lesson here, but it's still good to know. Anyway, next we have to find any invariant points. Are there any points on this pre-image that didn't move to a new location to create the image? No. All points on the original rectangle moved to different coordinates. Could you think of a translation that does have invariant points? Unlike reflecting, translations force every point on the pre-image to move in at least one direction. Therefore, translations will never have invariant points. So, for this entire lesson, we can put none for invariant points. Now we have to decide if the transformation is an isometry. When the rectangle moved to the left and down, did it get bigger or smaller? Did it get skinnier or wider? Since it maintained its shape and size, it is an isometry. What kind of translation would not be an isometry? All translations keep the same shape and size as the original. So we can safely say in this lesson that all translations are all isometries. So we've answered all parts of the question now. Now's a great time to go back to any parts of this video if you need clarification. Also, make sure your notes are looking great before moving on. Here's our second example. It says to translate the object 7 units right and 1 unit up, and find the following information. It's your turn to try this on your own, and I know you can do this. So pause the video and complete this problem. Here are the points C, A, T, and S on the pre-image. When we shift this quadrilateral 7 units right and 1 unit up, it'll land here. All the points on the quadrilateral moved right 7 units and up 1 unit. So, following this pattern, we can now label the vertices on the image. Next, we find any invariant points. We just found out in the previous example that every point on a pre-image has to move when a translation occurs. So there are not any invariant points. We also have the exact same quadrilateral in the image that we did in the pre-image. It's the same shape and size, so yes, this is an isometry, just as all translations are. Now that we've gone through 2 examples of translations, it's a great time to make some connections between what we've learned so far in this unit. So here's a question I want you to think about. What are some differences and similarities between reflections and translations? Think about this question as you go throughout the day today. You don't have to know the answer to this right now. I also want to challenge you to put that game, phone, and TV remote away and try to make some of your own artwork that uses both reflections and translations. I even skipped part of my favorite show last night to make an example for you. Yeah? Check out all the reflections and translations here. I think you can create an even better example than mine, so I challenge you to it. Now that you know how to perform translations of figures, we're going to discuss how to write the coordinate notation to describe translations in our next lesson. See you next time.